Hello, ARRL members and readers worldwide. I am Dave Kassler, call sign KE0OG, and I am the author of the Ask Dave column in every issue of QST. One of the recent articles that was in the July edition happens to be about magnetic loop antennas. As pointed out in the article, the term magnetic loop is a misnomer. Sort of. As it turns out, the small antenna in a loop like that, it's actually a tuned circuit with very high Q, has a little bit more magnetic radiation than electric radiation, so that's kind of how they get the term magnetic loops. But it's not a fully it doesn't just excite the magnetic portion of the electromagnetic field. It excites both the magnetic and the electric. So it's an electromagnetic field antenna. It's what is called, has classically in radio been called a small HF loop. Now I wanted to go over this and expand just a little bit on what was in the July 2022 QST column about mag loops and take a look at one. This one comes from Chameleon. It happens to be similar to one that they produced now, but this is the old P loop. I've had it for a few years now. They make the F loop now. And I wanted to show you what all is inside of this thing. That comes out. This comes out. All these little parts and pieces come out. There's some coax. There's a little hockey puck style capacitor that can be used to increase the bandwidth. Lots of pieces, and then the main part is this piece of coax. Now on this piece of coax, which has a nice little Velcro tab on it that you can undo, this is LMR 240, but the center conductor and the outer conductor are wired together. The center conductor doesn't matter at all. What matters is the outer conductor, and the reason that it matters is it's the actual radiator. We can attach this box to this clamp, if I can remember how to do it. It's been a while. Okay, very good. And we'll hook this on. We're going to hook this end here. Now this is a LMR 400 coax. The inner conductor and the outer conductor are soldered together in this, but it's only the outer conductor that matters. The inner conductor does not. And because of the skin effect, and I'm going to put this thing out here. Okay, now we'll take this right here. There's some really funny people who say this is easy. If you do it every day, I guess it is. Okay, now let's look at the parts on this. Now, this is the cable that is provided. They provide cable that has PL259s on the end, which I like. This goes over here. This makes for a magnetic loop antenna that's portable. There's a little tripod here you can put it on. This particular mag loop requires that you tune it from right here. There's no remote tuning. A lot of mag loops have remote tuning. So let's look at the parts. First of all, this is the feed line, and it comes in up here and feeds this small loop, and each side of these, this side goes into the center conductor, this side goes into the outer conductor, okay? Now technically this is balanced, so they've got choke balance right here. These are magnetic cores that are on this thing that keep any outside current from going down here, so that it's balanced up here but unbalanced to the receiver. Okay, that's a nice little touch from Chameleon. This is the driving loop. And you may say to yourself, that is awful small. Aren't you shorting the HF signal? And the answer is no, because you've got this great big old thing that picks up on that. This is the actual loop right here. This is a feeding method for the loop. There are different feeding methods. You could do a gamma match along this thing or something like that, but this is a loop feeding method. Now, what's in here? All the so-called mag loops have this. What is in here is, inside the magnetic loop is a capacitor. Now, for high power magnetic loops like the MFJ, you have to have the plates of the capacitor very far apart. Because if you put 100 watts into this thing, you'll have literally thousands of volts across that capacitor, and it will arc. So you need a much bigger capacitor in a mag loop that will handle a lot of power. The capacitor is the part here that changes the resonant frequency of the loop. And as it turns out, it doesn't take much. When you find this is operating properly, there's a little tool here called the Alex tune. This is from a guy in Brazil who makes these. You just clip this on there, and when it is in tune, that light will come on. And so if you're trying to retune it to a different frequency, you press the key down or whatever on that, and you retune it until the light is brightest, and that'll be right in tune. Otherwise, what you need to do is tune for max noise, and you tune it fairly slowly because it'll go past that point really fast. And then you tune it up so that you get the lowest SWR. You can get a very low SWR on these. And now, how well do they radiate? Well, as it turns out, they radiate about as well as a dipole. So if you put this up 10 or 15 feet, you can have pretty good results. But remember, if you tune 15 or 20 kilohertz off your HF frequency, you're going to have to slightly tweak the tuning. And that's where this little Alex tune can come in handy. Okay. Now, so here are the parts. The transmission line, the excitation loop, the main loop, and that has low voltage, high current at the top, and over here by the capacitor has very high voltage and no current. Okay, or very little current. Now, why are there two capacitors in there? Well, as it turns out, the radiation resistance on mag loops is very low, about 5 ohms. Okay, so for it to transmit, the actual ohmic resistance has to be less than that, much less than that. So these capacitors are in a butterfly arrangement where the stators are connected to either side here, okay, and then these two rotators are connected to each other by the rotator plate or shaft right there. And so the energy comes in through one, through the shaft, up to the other, and then out to the other set of plates, okay? That way there are no sliding connections or anything like that that could develop high resistance. This is a standard design for that. And this is a nice little about 8-to-1 tuner down here. So you can tune a little bit, and it doesn't tune the plates very much. It's still very, very touchy on the tune. Now, this is a little extra that comes from Alex Loop. And the Alex Loop, or Alex Tune, comes from Alex Loop, which is in Brazil. Okay, and you can get these separately I think through DX engineering. Okay, so that just gives you a little quick explanation of the parts of a magnetic loop. One of the nice things is most people have no clue what this is, so if it's kind of sitting out in your backyard and you've got a plastic lawn chair or something on either side of it, nobody will even notice it. It doesn't look like an antenna, but it can be a very good approach for where there are HOAs. You can also, if you have a balcony apartment, you can set this out on the balcony. Now up like this, it radiates mostly in the plane of the loop, and opposite the loop there's a null. One thing you can do about that is to mount it on its side, like this. And when you mount it on its side, it's omnidirectional all the way around. It has a null down and a null up. So it's not good for NVIS communications in this position because it's got a null pointing up. But you can still actually get a great deal of radiation out of this. So we've just used the chameleon P loop to demonstrate the different parts of a so-called mag loop, what is really a small HF loop, but I think the world calls them mag loops now. And just like we call the 20-meter band, the 20-meter band, even though there's nothing in it that has a wavelength of 20 meters, but it's just tradition. So there you have it. We learned a little bit about the small HF loop, commonly known as a magnetic loop, and until we next meet, 73.